Hey everybody! So today we are doing 7.9 applications with quadratic equations, specifically on finding the maximum area. All right, let's first recall two things from a while ago, area and perimeter of a rectangle. So say we have a rectangle with side length and width. We know that the area is length times width, and the perimeter is 2 times the width plus 2 times the length. So area is everything that's inside, perimeter is the outside length. All right, we're going to be using both of these equations on our next couple examples, so let's get into it. Okay, so say you have to fence off a section of your backyard for your pet. You want to create the largest rectangular area, but you only have 37 feet of fencing. The area will be attached to the back of your house, meaning that it's sharing an edge, so you don't need to fence that area. And then what are the dimensions of your dog's play area? So let's first start off with a visual. Try drawing out a picture of what's going on. Okay, so here is my picture. And what I want you guys to realize is with our rectangular area that we have, we can see that this side length that's attached to the house is not being used. So in this picture, we actually have two lengths and only one W. So let's write out everything that we know. We know the formula area is equal to length times width. And then we also know that the perimeter is basically the fencing. And for that, we can see that the perimeter or the amount of fencing that we have is 37 feet. So for that formula, it's going to be perimeter is 2W plus 2L. But in our case, our perimeter is 37, and we also only have one width, not two, because one of the widths is not being used for our fencing. Now with both of these equations, here and here, we are going to do a substitution. So for the second equation, we can actually solve for W and get W by itself by subtracting 2L to both sides. So we get 37 minus 2L is equal to W. And then from there, we're actually going to do a substitution. So I'm going to take this W and plug it into that first equation. So now we get area is equal to length times all of 37 minus 2L. But it's the whole thing. It's being multiplied, so we need to add in parentheses. All right, let's clean this equation up a little bit. We can distribute the L to both of them. So we get 37L minus 2L squared. And then we actually have a quadratic because we have a degree too. So now what we can do is let's write out our A, our B, and our C values. So in this one, our A is -2, our B is 37, and then our C is 0. So when we visually think about a quadratic, the maximum part of a quadratic function is the vertex. Remember that the vertex formula is x is equal to -b over 2a. But in this case, our x is actually L. So we're going to solve for L is equal to -37 over 2 times -2. And then when we plug that into the calculator, we get 9.25. So we know that here our L is 9.25. Okay, and then now we just need to find what our width would be. So our W from up here, we know that W is equal to 37 minus 2L. we know that L is 9.25. And then when we plug that into the calculator, we get 18.5. Okay, and then let's make sure we just finalize our answer. The length is 9.25, and we're talking about feet. And then width is 18.5 feet. And we can box our answer. Okay, second part of this question, let's add. Okay, so suppose it asked you what is the area so you can lay down turf for your dog to play on. So you want to know how much is the whole area. So all we have to do is just substitute what we know. We know area is length times width. And then we just substitute our L for 9.25 times the width is 18.5 from what we got right above over here. And then when we multiply that together, we get 171.125. And then this is feet squared because we're doing feet times feet. So there's our answer for area. And then now let's relate this to visually what does a quadratic look like and how does solving for the vertex actually giving us the maximum area. So off on the side, I'm going to show you guys a visual. Okay, so this is just the quadratic that we had over here graphed. And as you guys can see, that right here is our vertex, and that is the maximum part of our quadratic. So that's why it relates to finding the maximum area, because our area is what our quadratic is in terms of. So it's also in terms of length, and if you look right below here, that's about 9.25, which was our maximum length. And then if you look here to the left, it's about 171.125, which was our maximum area. This is our vertex, our point, length, and then area. Okay, so hopefully that kind of helps relate our quadratic, what we've been doing, why we solve for the vertex, and then what we just did in this example. Okay, let's move on to a second example. Okay, so next example reads, you were in charge of creating a rectangular section in the ocean where it is shark-proof. You have this really cool shark-proof fence material, but you only have 121 yards of it. What are the dimensions, length and width, to create this safe swimming area? So just like our previous problem, it's really great and helpful to create a visual when you're dealing with application problems. So let's start with that. Okay, so looking at our picture to the right, let's label a few things. We've got our fenced off swimming area, and we've got a width and another width and then a length. And obviously we don't need to fence off the section to the beach because that's already a place that the sharks can't go. Okay, so let's start off with our two formulas. Area is length times width, and then the perimeter is 2W plus, and in this problem we only have one L, so plus L. Reading the problem, let's notice that we have 121 yards of our fencing. So we know that the perimeter P is 121. So we have 121 equals 2W plus L. And then from there, we can actually solve for our L value by subtracting 2W to both sides. And then there it is. So now our next step is combining our area and perimeter equations. We can take this L and substitute it into our area equation. So we get 121 minus 2W, and the whole thing is times W. Okay, we have a binomial times a monomial, so let's use distributive, got arrows, And now we have A equals 121W minus 2W squared, giving us a quadratic. Let's label our A, our B, and our C values. So A is -2, B is 121, and C is 0. Okay, and we're trying to maximize our dimensions so we have the biggest safe swimming area. So let's actually write out our vertex formula. And in this case, it's W is equal to -B over 2A. So to find the vertex, that's going to help us find our maximum dimensions. So plug in our B. So -121 over 2 times -2, plugging in our A value. And then we get 30.25 is our width. And then if we want to solve for our length, we've got that formula here. So that's 121 minus 2W. We know that W is 30.25. So just plug that in for W. And then our length, when we calculate that, is 60.5. And then going back to what the problem asked, what are the dimensions to create the safe swimming area? Let's just write them out formally. So width is 30.25 yards. And then length is 60.5 yards as our final answer. So that is it for today. You guys will be working on bookwork 7.9 posted on Google Classroom. And then if you guys have stayed for this whole video and have been watching, I am posting a little zebra there because your magic word for this week is a zebra. All right, magic word for this week is zebra. All right, have a great day, everybody.